Good day, everybody. How are you all? Today we are going to talk about chi-square test for variance. Okay, so I'll share my computer screen with you. So you see the symbol, it looks like capital X square, but it is chi-square in Greek. It's chi-square test for variance or standard deviation. Remember, variance is the square of the standard deviation. So chi-square test for variance or standard deviation. So there can be three possibilities for the null hypothesis and the alternate hypothesis. Okay. The first one is H0 chi-square equal to chi0 square, where the chi0 is equal to hypothesized population variance. And the corresponding alternate hypothesis can be chi-square greater than chi0 square. Okay. So this is a right tail test. Okay. So this is one set of tests. The second one can be null hypothesis chi-square equal to chi0 square, and alternate hypothesis is chi-square less than chi0 square. So this is a left tail test. As you remember, the tail or the direction of the test is given by the direction of the alternate hypothesis. In the case of less than, the two slanted lines indicating less than meet at an edge pointing to the left. It's a left tail test. Left tail test. In case of right tailed in the alternate, the two slanted lines indicating greater than meet at an edge pointing to the right. It's a right tail test. And then there is a third situation which can be H0 is sigma square equal to sigma 0 square, and alternate is sigma square not equal to sigma 0 square. So this is a two-tail test. Two-tail test means the rejection region can fall in either the left tail or in the right tail of the distribution. Okay. Okay, so how do we do this test? So first, we have to make sure that the following assumptions are met. So I'll create some space for myself. Assumptions for the chi-square test. For a single variance. What are the assumptions? First assumption is the sample must be randomly selected from the population. Second one is the population must be normally distributed. Must be normally distributed for the variable under study. For example, if we are talking about heights of people, the heights of the people must be normally distributed under study. Okay. And part 3, the observations must be independent of one another. Must be independent of one another. That is what we select for the first item in the sample will not influence what we'll select for the second item in the sample. Okay. So we have to calculate a test statistic. So let's create some space. So test statistic. So for chi-square test. Again, it is spelled as CHI but pronounced as chi. Chi-square test for a simple variance. Okay. And that test statistic is chi-square is equal to n minus 1 times s square divided by chi0 square. So this chi-square, the test with n minus 1 with degrees of freedom equal to n minus 1, and where n is your sample size, s square is sample variance, and chi-square, sigma square is, or sigma 0 square is hypothesized population variance that comes from null hypothesis. Okay. So what are the steps? Let's take care of that. Okay. the steps steps in hypothesis testing. Okay. The step one is state 80 to state HA 3, compare or calculate the test statistic. The number 4 is compare the test statistic the critical value. Oh, sorry, to the critical value of chi-square. Okay, and then make the decision based on the location of the test statistic with respect to the critical value. Okay, so I'll show you an example of how to get the critical value. So let me create some space. Okay. 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 The critical value will depend on degrees of freedom and degrees of freedom, comma, and the direction of the alternate hypothesis. Okay. Critical values are listed in tables. Critical values of chi-square are listed in tables such as the one on the web, and the address is I'll give you. H T, this is H TPS. I always use this one, colon, double slash, people dot richland dot edu slash forward slash James, last name of the professor who produced this table, James lecture forward slash M170 slash forward slash TBL dash CHI dot HTML. So I use this website to get the chi-square, critical values of chi-square. So let's take an example, okay? So I'll create some more space. So example, so this is a problem. An instructor wants to determine whether the variance in scores of 25 students in her class is less than the variance in the population. In the population. The variance of the class the variance of the class of the class is 198. Okay. Is there enough evidence to support the claim that the variance of the students variance of course of the students in her class is less than the population variance value of 225 at level of significance that is alpha is equal to 0.05. Assume the scores are normally distributed. This is important. Are normally distributed. Okay. So I'll create some space and solve this problem. Okay. So first we'll state the null hypothesis. H sub 0 is sigma square is equal to 225. And H sub A, that's the alternate hypothesis that the teacher wants to test, is less than 225. Okay. Then my sample size n is equal to 25. My degrees of freedom is n minus 1 is 25 minus 1 is equal to 24. Alpha, which is the level of significance. What is level of significance? It is the maximum probability of rejecting H0 when it is true. It is 0.05. Okay. So we have to refer to the table. Refer to the table which I have on the website I have stated above. Okay. So we have to go to the website and find out the critical value. Okay. But before we do that, let's draw the diagram of the chi-square distribution. Okay. So chi-square distribution looks like this. This is your chi-square value on the horizontal axis, probability on the vertical axis. And chi-squares look like this. Okay. Okay. So notice chi-square values are all positive. Okay. And chi-square starts from 0. Okay. And chi-square values extend to infinity. Chi-square values depend on degrees of freedom. Degrees of freedom. which is given by n minus 1. In our case, n minus 1 is 24. That's our degrees of freedom. Okay. So we have to look up degree first. The column is like this. If you go to the table, chi-square table looks like this. Chi-square table usually looks like this. Okay. So in the first column, you have degrees of freedom. Okay. So you locate 24 degrees of freedom. Okay. Now this is a left tail test. So that means area in the left tail, this portion, area is 0.05. And over here, this area is 0.05. So area in the right tail is 0.95. So if you go to the table, okay, the table is in that website that I have listed. I have a textbook which has got a table also at the back, hopefully. So let's see if I can find that table from my textbook. Yes, I have the table. So my area in the left tail is 0.05. Area in the right tail is 1 minus 0.05 is 0.95. My degrees of freedom is 24. So first I look at 24 in the first column, and then on the top row, okay, on the top row are areas, okay, in the right tail. So 24 and 0.95, okay. So since my area in the right tail, so these are numbers on the top row. Over here, there's a top row, okay. Like the first is 0.995. Next one is 0.99. Okay. Next one is 0.975. And next one is 0.95. Okay. This is the area in the right tail. In the right tail. So in my case, area in the right tail is 0.95 as I have shown in the diagram. And I locate in the degrees of freedom column the number 24. I draw a horizontal line through 24 and a vertical line through 0.95. While it intersects is the critical value is 12.401. This critical value is 12.401. Okay, so I'll create some space. Okay. So this critical value is 12.401. This is my critical value. So chi-square critical value is 12.401. Now calculate the test statistic. Calculate the test statistic. Chi-square, which is n minus 1 s square divided by chi0 square. Okay. So let's create some more. Oh, I made a mistake. Let me correct that. Divided by sigma 0 square, the hypothesized variance. Okay. And let me create some space now. Okay. So my test statistic chi-square test statistic chi-square is n minus 1, 25 minus 1. What is my s square? So I have to remember that. That is the sample variance. I believe it was 198 and the hypothesized value was 225. Okay. So sample variance was 198 and the the hypothesized variance from the null hypothesis was 225. So this is 24 multiplied by 198 divided by 225. Enter in your calculator. Is equal to, so chi-square is equal to 24 times 198 divided by 225, and that is equal to 21.12. Okay. Was it 25 or 20? Well, let me make sure I have done it correctly. Yeah. Okay. 21.12. Okay. Now notice your I will show it on the diagram. So let's change the color of the ink. Let's make it red. Now let's make it. Okay. So you have calculated the test statistic, the critical value out here. If I can put it right, is over here, 12.401, and you have calculated a test statistic of 21.12, which is greater than 12.40. Okay. And so what is your decision? Let me write it down. Decision. Since the test statistic value of 21.12 is greater than the critical value of 12.401. Okay. The decision is do not reject 80. Okay. So let me create some more space. Note, if the test statistic value would have been less than the critical value of 12.401, then we would have rejected it. Okay, but here the test statistic is greater than the critical value. Okay, so let me create a little bit more space. So decision is do not reject H0, and conclusion is at alpha equal to 0.05, there is not enough evidence to support HA, which states sigma square is less than 225. Okay. So I'll stop here today. If you have any question or comment, please write me a note. I'll get back to you as soon as possible. And if you like this video, please give me a thumbs up. If you like this video, please share this with your friend. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll see you next time with another interesting problem, interesting solution. Take care. Have a nice day.